Okay, I'm going to talk about condensation polymers. Now, we've come across addition polymers last year, where that's when you get alkenes, and to form the polymer, you lose the double bond in between them, and you form a new bond between the two carbons. Okay, like that, and that's what carries on forever. Okay, that's called an addition polymer. I won't really talk about that here because that's in an earlier topic, the alkenes topic. What we're going to talk about is a different class of polymers called condensation polymers, and they're going to be polyesters. We've got an ester linkage in them, and polyamides. Okay, so let's have a look at that. Right, so here we've got an ester. I'll rub this out. Okay, so we've got an ester there. Now, when that reacts, so we've got a carboxylic acid, the black molecule, propanoic acid, and we've got methanol. And when they react, you are going to form, so you lose the water here. Let's do it here instead. Right, you're going to lose the elements of water. Because you get nucleophilic attack onto that oxygen onto the carbon. So you lose the water, so you lose that. You keep that oxygen, and you form this polymer, this ester, not polymer. Okay, so that can't polymerize, but imagine instead of it being a dead end here, let's just rub that out, and let's change that. Let's make this a diol, so ethane 1,2 diol. And let's say we make, instead of having a just a CH3 there, let's make that a carboxylic acid on that end. So it's a dicarboxylic acid. Right, and then we could have another one of these here. Okay, we can have another carboxylic acid on this end here. Okay, and then if we just see what's going to happen there, so we're going to lose water here as well, and lose water there, and you can see we're going to start forming a polymer which could carry on forever. Okay, so I'll just draw a bit of it, CH2, CH2, O, and then we've got the carbonyl. The carboxylic acid will carry on like that. I've got to rub that end off there. That is now a carboxylic acid carbon, and that is bonded to the alcohol, and make that a diol there. That's OH there. Okay, so you get the idea that this thing could carry on forever. And of course, at each point there, you get one molecule of water produced. That's why it's called a condensation polymer, because you also make the water. Now, rather than writing that out, you're obviously just going to write down one repeating unit. So when they ask you to draw a repeating unit, you shouldn't repeat anything twice, but you should include everything that you need to. So I'm going to start it off there, and the square bracket. And the difficult thing is to see where should we end it. Where should we end the square bracket? So we've got the dicarboxylic acid here. This is all new. We've got the diol. This is all new. When we get to here, we're repeating the carboxylic acid bit again. So we end the square bracket there. So be careful that you put the square bracket in the right place. You know, for example, if you put it there, you'd be wrong and you'd lose a mark. Okay. So that is a polyester. And there is one example of a polyester that it actually says that you need to know in the exam, in the specification, and it is called terylene. That's its trade name, and it is a monomer of this stuff, which is called benzene 1,4-dicarboxylic acid. And the same diol alcohols we've got up there, ethane diol, ethane 1,2-diol. Okay, so I'm just going to draw a repeating unit of it now, but I'll write down the name of that because it's worth remembering that name, benzene 1,4-dicarboxylic acid. Okay, so what's going to happen there is we're going to lose the water here. Going to lose water there, and we're going to lose water on the other side as well, and we're going to lose water there. Right, so let's just undo that and then draw the repeating unit. So I think probably right, I'm going to try and move this across now. If it lets me, it is going to let me. Right, that's going to go there. I'm going to draw a new bond there. I'm going to rub that out because this is going to be, okay, I'm going to end my repeating unit there. I need to get rid of that. And that's where the repeating unit starts. So that the benzene 1,4-dicarboxylic acid was the monomer. I'm going to get rid of that now because it's not the monomer anymore. And we formed that, and this is pterylene, and that is a repeating unit of the polyester pterylene. Okay, now let's talk about polyamides. So I'm going to do a very similar thing again. I think we get rid of all of this. Right, so if you have an amide, you usually have an acyl chloride. And you're going to react that with an amine. Let's have ethylamine. So you're going to lose HCl there. And the product is going to be an N-substituted amide, which I said is very like an ester, except you just swap the oxygen atom for a nitrogen atom. Okay, so that would be N-ethyl ethanamide, that one. But so that can't polymerize, so we're just going to make it carry on from both ends. So we're going to turn that into a diamine, got an amino group on both ends, and we're going to turn this into a diacyl chloride. So you've got an acyl chloride at both ends. So we turn that to a 2. Okay. So let's look at the monomer. What's that going to look like? So if you get rid of that, and this is going to carry on with another acyl chloride here, isn't it? And so on. And at this end, we're going to have, that's going to carry on there. So if I want to draw the repeating unit, right, I should start off like, let's start off at the start of this, sorry, that's wrong there. That would be an NH there, wouldn't it? Let's start off the repeating unit here, the start of the diacyl chloride monomer. You're going to get all that, then you get the amine bit, and it's going to stop there. That's the repeating unit in there between the purple brackets, and that's called a polyamide. Right, before we finish, it does mention, let's think about the kind of intermolecular forces you could get between different polyamide chains? Well, the this nitrogen here can hydrogen bond because it's a this hydrogen can, it's got a partially positive hydrogen attached to a very negative nitrogen. So that's a denuded proton that can form hydrogen bonds to a nitrogen on another chain of the polyamide, or it could be to the carbonyl, because that's got a lone pair on the oxygen. That would also form hydrogen bonds. So you can get hydrogen bonds between chains. In polyamides. Okay, there are two polyamides which you need to know about on the specification, so I'm going to name them now. One is 6,6 nylon, and the reason why it's called that is because it's formed from a monomer which is hexane dioic acid. So you've got 6 carbons here. So there's hexane dioic acid, or it can be hexane dioal chloride. That will work as well. And you've got hexa 1,6-diamine. So you've got an amine group on this end. You've got 6 CH2s, carbon chain 6 long, and an amine group at the other end. Right, let's just have a look at the polymer that's going to form. Well, it's going to be the repeating unit. You'd be a carbon CH2 4 times. So this is the start of the repeating unit, and then you're going to get your diamine bit here. There's 6 carbons there, and another amino group, and then that's going to carry on with another of the hexane dioic acid there. The repeating unit is going to end up there, and that's called 6,6 nylon. And it can form hydrogen bonds between one chain and another. You've got these hydrogens here, which are delta positive. They can form hydrogen bonds. You've got the lone pairs on these two nitrogens. You've got the lone pairs on the oxygens. And so that will form hydrogen bonds. The other one you need to know about is called Kevlar, okay? And Kevlar is made from benzene 1,4-dicarboxylic acid again. And the diamine is 1,4-diaminobenzene. So you've got a benzene ring with an amine group at each end. Kevlar is a very tough polymer. They use it in to strengthen tires to stop them getting punctures, and they use it in bulletproof vests. So when it polymerizes, you're going to lose that there. Rub that out. You're going to form a new bond between the carbon and the hydrogen. That's your amide linkage, and the same at this end. I'll just draw the repeating unit. Get rid of that, and that's going to go off. Right, so the repeating unit, I'm going to start that there. I'm going to finish it there, and that is Kevlar. And again, that can form hydrogen bonds between different Kevlar chains. Okay, right. Just before, I should show that the polyester. If you draw out a section of polyester, you can't get any hydrogen bonding there because we just have a look. We've got right. This would be from the carboxylic acid, say. So you've got propandioic acid is one monomer, and then we've got ethanol, ethane 1,2-diol as the other one. There's a repeating unit. You're only going to get dipole-dipole interactions between these two, between different polyester chains, because there are no hydrogens. Like you have a hydrogen attached to a nitrogen on this one, don't you? There's no hydrogen attached to oxygen. So you will get dipole-dipole interactions, you get van der Waals, but no H bonding. Okay.